Hello students, today we have to study the energy of a satellite. On your screen we have Earth. Earth is having a mass of me and r is the radius of the Earth. H represents the height at which the satellite has been placed above the surface of the Earth, and the small r, it represents the distance from the center of the Earth, and it is equal to r plus h. The satellite is moving with an orbital velocity of v0 and it is having a mass m. Now, when a satellite is moving around, it has certain energy. Why it has energy? Two reasons. The first reason is satellite is having a velocity. It has got velocity v0 and it has got mass m. So it will be having kinetic energy. Now, the second reason, there's always a force of attraction towards the Earth, gravitational pull, and against this force, a displacement has been created. What does this mean? What we expect, due to the gravitational pull, the satellite should be on the Earth, but there is some energy, some work has been done on satellite which has pushed it apart from the Earth. That gives it potential energy. So satellite is having both kinds of energies, that is potential energy as well as kinetic energy. So the potential energy of a satellite is given by minus g me m divided by r, where g is the gravitational constant, me is the mass of the Earth, m mass of satellite, and r is the distance from the surface of the Earth. Now this minus, this is because of the force of, this is due to the force of attraction. Similarly, we have kinetic energy of a satellite, that is given by half of m v naught square, where m is the mass of satellite and v naught is the orbital velocity. And we already know, we have calculated in our previous lectures what orbital velocity is given by. It is given by v naught is equal to root of gme divided by r. So we will substitute this v naught in this equation and we'll get kinetic energy as half of mgme divided by r. So what will be the total energy of a satellite? It will be kinetic energy plus potential energy. So substituting the values of kinetic energy and potential energy, we get the total energy of satellite as minus half of mgme divided by r. So the total energy is negative, that is, it is less than 0. When energy is less than 0, we say the orbit is bound orbit. So the orbit is bound orbit. So what does a bound orbit means? It means when the energy is negative, the satellite is bound in an orbit revolving around the Earth. It cannot leave the Earth. Same is the true for the Earth, as Earth revolves around the Sun. So in case of Earth also, the energy will be less than 0. Or we can say for circular orbits, total energy will be less than 0. And such type of orbits are called as bound orbits. Now we have, you see here, one second. Now if you see here, the total energy, and if you compare the potential energy of a satellite, the total energy given by this term and the potential energy given by this term. Now you can see the total energy of a satellite is actually half of its potential energy. This may sound a bit strange, but it is like that. The total energy of a satellite is equal to its half of potential energy. Now next we have to see, what if a satellite wants to leave the orbit of Earth and be free, and how much energy it needs. Now if a satellite wants to leave its duty of orbiting around the Earth and want to be free, so this can happen only if the velocity of satellite increases, which means its kinetic energy increases. The satellite is short of certain energy, and if you give satellite the same amount of energy which it is short of. Sorry, one second. And if you give satellite the same amount of energy which satellite is short of, it will be free to move. It will not be then bound in an orbit around the earth. For example, if we take this is earth here, and if there is some object moving, some particle moving, and the earth, this is earth, it is not having any influence on this particle here. So we can say the energy of the particle with respect to the earth is zero. So if you want the satellite to be free from the influence of the earth's gravitational pull, its energy should be zero. So the energy of satellite is minus half of g me divide m divided by r. So if we supply the same amount of energy to the satellite, the total energy of the satellite will be zero. So if we want the satellite to stop orbiting around the earth and be free, we have to supply it energy that is equal to 1 half of g me m divided by r. This way the total energy of the satellite will be zero with respect to the earth. It will be free from the rotation. So we can say it should exist at infinity, and that's how the earth's gravitational pull will not have any effect on the satellite, and same will be true for other planets as well. So this energy is called as binding energy. So what is a binding energy? Binding energy is the minimum amount of energy which if you give to this satellite, it will be free from the influence of the gravitational force of the earth. So that is the binding energy. And whenever total energy is less than zero, we say it is a bound orbit. Thank you.